Studies have suggested the malabsorption of micronutrients such as folate, chromium, selenium, omega-3 fatty acids, and zinc is associated with the development of acne. Welcome to episode 3 of series 2 of the Adult Acne Podcast. And in this episode, I'll be explaining why the gut microbiome is so important to skin health and acne, and what we can do to help optimize our gut microbiome to help in the process of achieving clear skin every day for the rest of your life. This was originally part of an episode that I recorded previously in my other podcast, The Radical Health Rebel. Enjoy. So your skin functions as an exterior surface between the human body and the environment, acting as a physical barrier to prevent the invasion of foreign microbes while providing a home for the commensal microbiota. The harsh physical landscape of skin, particularly the dry, nutrient-poor, acidic environment, also contributes to the adversity that pathogens face when colonizing human skin. Despite this, the skin is colonized by a diverse microbiota. Our skin is completely coated in microbes. There are approximately 1 million bacteria composed of hundreds of species on every square centimeter of our body. Our skin is home to millions of bacteria, fungi, and viruses that compose the skin microbiota. Skin microorganisms have essential roles in the protection against invading pathogens, the education of our immune systems, and the breakdown of natural products like the microbes of our gut. As the largest organ in the human body, the skin is colonized by beneficial microorganisms, but when the barrier is broken or the balance between commensals and pathogens is disturbed, skin disease or even systemic disease can result. Studying the composition of the microbiota at different sites may be valuable for finding the cause of most skin disorders, such as acne, as well as eczema, dermatitis, or psoriasis. Structurally, the skin is composed of 2 distinct layers, the epidermis and the dermis. The outermost, the epidermis, is comprised of layers of differentiated keratinocytes. The top layer of the epidermis, or the stratum corneum, is composed of terminally differentiated enucleated keratinocytes, also known as squames, that are chemically cross-linked to fortify the barrier of the skin. Now, a keratinocyte is a cell of the epidermis that produces keratin. Sweat glands are important for the maintenance of body temperature through the evaporation of water, which also acidifies the skin, making conditions unfavorable for the growth and colonization of certain microorganisms. Sweat contains antimicrobial molecules such as free fatty acids and antimicrobial peptides that inhibit microbial colonization. Connected to the hair follicle and denser in oily sites, the sebaceous glands secrete lipid-rich sebum, a hydrophobic coating that lubricates and provides an antibacterial shield for hair and skin. The type of microbial communities on the skin is dependent on the physiology of the skin site, with changes in the relative abundance of the types of bacteria associated with moist, dry, and sebaceous microenvironments. Highly sebaceous sites, such as the face, the chest, and the back, are dominated by lipophilic Propionibacterium species. So lipophilic means having an affinity for lipids, such as fats. Bacteria that thrive in humid environments, such as the Staphylococcus and Corynebacterium species, were most abundant in moist areas, including the bends of the elbows and the feet. Fungal community composition is similar across core body sites, regardless of its physiology. So if you have ever wondered, as I did, why you only tend to get acne on the face, chest, and back, and not on the arms, legs, or lower torso, it's likely because the face, chest, and back are sebaceous sites dominated by the acne-related Propionibacterium species of bacteria, and it's the Cutibacterium acnes that's a member of the Propionibacterium species. Now, fungi of the genus Malassezia predominate on the core and arms, whereas foot sites are colonized by a more diverse combination of Malassezia, Aspergillus, Cryptococcus, Rhodotorula, Epicoccum, and other species. Compared to the intestines, the skin lacks many nutrients beyond basic proteins and lipids. To survive in such a cool, acidic, and dry environment, our skin's resident microbiota has adapted to utilize resources present in sweat, sebum, and the stratum corneum. C. acnes, for example, can thrive in the anoxic, which means greatly deficient in oxygen, sebaceous gland, using proteases to liberate the amino acid arginine from the skin proteins and lipases to degrade the triglyceride lipids in sebum. This releases free fatty acids, which promote bacterial adherence. Sebum levels on the cheek are abundant with Propionibacterium species. The Malassezia species of fungi is the most abundant fungal organism on the skin. It coexists with C. acnes and other bacteria. Malassezia is the fungus thought to cause fungal acne. One study showed acne lesions were significantly reduced after administration of antifungal drugs. The authors suggested that Malassezia and not C. acnes was potentially the cause of acne not responding to treatment. The findings from several other studies support this hypothesis. One study reported that Malassezia restrictor and Malassezia globosa can be isolated from young acne patients. Another study showed the lipase activity of Malassezia is around 100 times higher than that of P. acnes. Malassezia can increase fatty acid production, increase skin cell development in the hair follicles, potentially leading to a blockage and increase inflammation via activation of an immune response. It's the immune response that causes the acne lesion's redness. How much Malassezia levels are affected on the skin via the gut-skin axis is unclear, but it's not beyond the scope of possibility that a Malassezia overgrowth in the gut may be capable of relocating from the gut to the skin via the gut-skin axis. It's important, therefore, to optimize your gut microbiome, which is covered in chapter 6 of my book, whether you have bacterial or fungal acne. Looking at the gut-skin axis, chronic skin conditions such as acne are complex and affected by many factors. Current evidence offers insight into how the skin and gut microbiome are connected. There is evidence the gut microbiome influences other organ systems, and it has a particularly complex connection to the skin. Amir was a 42-year-old professional man suffering from acne. He was overweight, suffering from low confidence, and had very low energy levels when he first came to see me. He was also spending £400 per month on products to cover up his acne. His skin was very oily, his face and scalp were covered in acne, and he worried that it might start to affect his work. Upon testing his gut microbiome, it was discovered that he did have a minor imbalance of gut microbes, including Staphylococcus aureus, which is often linked to skin conditions. He had hormonal imbalances, which would have affected his energy levels, and a number of food sensitivities that may have also been causing his acne. He was a slow starter in terms of changing his diet and lifestyle, and his progress was initially slow to non-existent. Amir was also given supplementation to help rebalance his gut microbiome and his hormones. A few months into the program, we had a little heart-to-heart, and I made it clear to him that unless he fully committed to the program, he simply wasn't going to be successful. I half expected Amir to throw in the towel at that point, but to my surprise, it was just the kick up the backside that he needed. He knuckled down and started eating right for his metabolic type, finally started eliminating sugar from his diet with a lot of perseverance, and within a few weeks, his skin improved to the point where he had clear skin for the first time in 30 years. If you're ready to say goodbye to adult acne for good, schedule your acne breakthrough call with me now at www.eliminateadultacne.com, and let's create a customized plan for clear, beautiful skin that lasts a lifetime. Don't wait any longer. Take control of your skin today. Commensal or friendly bacteria in the gut may help modulate systemic immunity and reduce inflammation, which has an impact on skin health. For example, short-chain fatty acids are produced by commensal gut microbes when they ferment dietary fiber. Short-chain fatty acids regulate the life cycle of immune cells and have a protective role against the development of inflammatory disorders. This is relevant as acne has an inflammatory component. Another short-chain fatty acid, butyrate, can positively modulate the activity of inflammatory cells such as cytokines and suppress inflammatory immune responses and therefore acne. Under certain conditions, commensal bacteria can undergrow and pathogenic bacteria and other microbes can thrive. This creates a dysbiosis, which is an imbalance in the amounts and types of bacteria in the gut, which can have a negative impact on your health. Chemicals produced by these gut microbes may enter the bloodstream, build up in the skin, and impair skin health. This may occur due to the increased gut permeability, otherwise known as a leaky gut syndrome. If you have a healthy, diverse gut microbiome, it greatly increases, if not ensures, your health. Research has suggested a dysbiotic gut microbiome leads to disease and may be associated with skin disorders. Rather than addressing the skin alone, it's crucial to consider the role of the gut microbiome in skin conditions, including acne. There is evidence that acne is an inflammatory disease, and gut health may play a role in its development. Low levels of stomach acid are often associated with acne, and a more alkaline gastric pH enables bacteria from the colon to access the small intestine. This can cause gut dysbiosis, malabsorption of nutrients, and small intestinal bacterial overgrowth, known as SIBO. Nutrient malabsorption may play a role in the development of acne, as bacterial overgrowth competes with cells in your body for nutrients, impairing the absorption of nutrients to your cells. Studies have suggested the malabsorption of micronutrients such as folate, chromium, selenium, omega-3 fatty acids, and zinc is associated with the development of acne. The production of toxic metabolites resulting from SIBO can increase gut permeability or leaky gut syndrome, leading to systemic inflammation with an association with acne. Factors associated with a modern lifestyle, such as antibiotic use, psychological and physical stress, and diet, can adversely affect the gut microbiome, leading to gut dysbiosis and its downstream effects. As I alluded to earlier, research has shown that antibiotic use can significantly cause unfavorable changes in the balance of the commensal gut microbes, leading to an increased susceptibility to pathogenic microbes in the gut, an overgrowth of fungi or Clostridium difficile, and reduced production of short-chain fatty acids. Stress also exerts unfavorable changes in the gut, including a decreased release of stomach acid and changes in gut motility, either constipation and/or diarrhea, creating an environment less favorable to the proliferation of beneficial bacteria. Psychological stress lowers mucin production in the gut, decreases immunoglobulin A or IgA. So IgA is an antibody, and it causes a substantial and ongoing increase in stress hormones, all of which can lower defenses against pathogenic microbes in the gut, allowing for their proliferation. Therefore, reducing overall stress and having stress reduction behaviors in place, such as meditation, yoga, Tai Chi, or Qigong, is strongly advised. Dietary intake shapes the makeup and metabolic activities of gut microbes. Some diets promote the proliferation of beneficial microbes, while other diets lead to unhealthy gut microbiome activity. A varied diet maximizes your nutrition and gut microbiome. Dietary restriction and the overuse of elimination diets can decrease gut microbiome diversity and introduce you to potential nutrient deficiencies. So what causes acne? Well, according to the UK's NHS website, it states, and I quote, "Acne myths. Despite being one of the most widespread skin conditions, acne is also one of the most poorly understood. There are many myths and misconceptions about it. In inverted commas, acne is caused by poor diet. So far, research has not found any foods that cause acne. Eating a healthy diet is recommended because it's good for your heart and your health in general." End of quote. I share this information because, it's just further evidence that the current medical paradigm does not believe diet is related to acne, and that there is no research suggesting that food or diet can cause acne. So that's it for today's episode. Make sure to stay tuned for future episodes where I will be digging deeper on how to optimize your diet for an optimal gut microbiome and ultimately clear skin. And if you can't wait for the future episodes, you can also check out episodes 9 and 10 from series 1, where I discuss the acne elimination diet, or you can purchase a copy of my book, Eliminating Adult Acne for Good, which is available from all major online bookstores, or you can order directly from my website at www.eliminateadultacne.com/books. And don't forget to send me your acne questions, and make sure to join me next time for more great information on how to eliminate your adult acne on the Adult Acne Podcast. And don't forget, make sure to like this video, comment below, subscribe to the channel, and thanks for watching.